Hi, Samantha. Thanks, Roy. How are you?
Oh, good. Hello, Professor. I'm good. How are you?
I'm good, thank you.
You're welcome.
We can check out the lab for today and do sequence and series in C++. We'll start in a couple minutes. Hello, everyone. Let me share screen. You can download the lab, take a look at it, and we'll start in a couple minutes, okay? Let me open up my REPL. So before we start, do you have any questions? No question? Okay. All right, so let's go ahead and get started. So today we are going to do lab 8, which covers sequence and series in C++. We are going to mainly hit arithmetic and geometric. So in each of the exercise, just like the last few labs, we are going to do some calculation along with some programming. So to start, we are going to review arithmetic sequence, and it is a sequence in that each term is going to be equal to the preceding term plus a constant. So you would then add, right, a constant based on what we talked about on Tuesday. So in exercise 1, you given the arithmetic sequence 2, 5, 8, 11, 14. In this sequence, two is the starting term. Sorry, there's a typo here. The starting term of the series, and then the common difference is going to be 3. So we simply take the next term, which is 5, and we subtract 2 to give us the difference. Or we can take 8, subtract 5, we would have a difference. So we can write T1 is 2, T2 is 2 plus 2 minus 1. So we simply plug in the n, where n is the position of that particular term. Then subsequently, we would then multiply it by 3, which is going to be our difference. Okay, so this is the equation that we're going to work with in the program. Now, in the program, we are going to use the nth value, which is going to be 5. So basically, you hard code that in. So when we look at the program, here's our program. So at the top, we're going to include algorithm. We're going to include IO stream. Algorithm is because we are going to use the equation to be able to calculate. And we have a function called nth of AP, which is arithmetic progression. So this is a function and its data type is integer. And for the argument, we are going to use variable A, variable D, and variable N. And all of these are part of your equation. Okay. Then from the function, we want to return a plus n minus 1 times d, which is our arithmetic progression or arithmetic sequence equation. So it's pretty simple. Then in our main, we are going to define what a is. And so variable a is going to initialize at 3. Variable d is going to initialize as 5. And variable n is going to be, let me double check, let me fix that. It should be at 5. Okay. So here it should be 5 to start. And we want to find out what value it would be on the 5th term of our sequence. That's what we're calculating using this program. So if you want to find out 100th term, you would simply replace the nth value, right? It's like plugging in the numbers into your equation and calculate that out. So we are going to go ahead and run this. So on the 5th term, it shows me that my value is 23. Okay. And then when we run this, we also need to verify that the output is correct. So in the exercise 1, the first step is for you to put the program into your IDE and run the program. And this is a very simple program in that you have one equation, one function that's going to incorporate the equation for arithmetic sequence. And then you have the main function in which we initialize the values for our variable that we use in the equation. And we simply call on the function, right, that we previously defined here. So when it returns in the main, you have to call on that function and you want to output the value because we want to know what that value would be at the end position. So in this case, it will be the 5th term, and the 5th term, it gives us 23. And you don't have to include all the comments. If you like to put the comments, you can, so that way you can follow it. Then after you complete writing the program, you would run the program and take a picture or a screen capture of your code and output. Then after that, we are going to calculate manually to verify that the output is correct. It should be, but we want to check. So it tells us for 1A in that we are going to calculate the nth term for the above program using the equation T of n is going to be a plus n minus 1 times d. So we want to go from the 1st term to the 5th term, or you can plug that in, right? So here I basically did some of it. So here's the equation. Our 1st term is 2, which is defined in the main function. Our distance is 5, which is also defined in the main function. Then we are going to go through, and you can do them step by step, or, you know, as you go through, you can go from starting at 1, and then for the 5th term, you simply plug that in. 5 minus 1 times d, which is 5. Okay. So I have here T of 1 we know that that's going to be 2, as that will be the first term. And if you put the nth value in, you should get a 2. So 2, right, plus 0 times 5, which gives you 2. The second term, we would then plug n in here, and our a and d. That gives us 7. And then for the next term, we repeat the process. N is 3, and we plug that into the equation, we get 12. So for the fifth term, that's what we're trying to find out. 2 plus 5 minus 1, which is 4. 4 times 5 is 20. And so that will give us the answer. Okay. So now when you look at this, I'm sorry, A is 3, right, on mine. So let me double check your code to see if I modify. Yep. So let me change my A here. It should be 22. Okay. So after we plug that in, we should have 22. Now, if we need to find the 20th term for 1b, we simply use the equation. We plug in n is 20. So 2 plus 20 minus 1 times 5. So we can bring out our calculator. So I have 19 times 5 plus 2. So it should be 97. Now we can test that. If we modify this and put in 20 here, and we run the program, we should have 97 as in the same answer. Okay. So what we did for 1b is we would calculate out what would be the 20th term by putting n as 20. And that will give us 97. And we want to also verify that the program is correct. So we would go to the main and we would change up our nth value to be 20. We run the program and it tells us it's 97. So here I should have that my calculation matches, right? Any question with 1A, B, and C? Now, if it doesn't match, what you have to do is you have to take a look at your program. As what I've seen earlier. What my A was not the same as what we intended to use. So make sure that you verify. So after that, you determine your output from the program is comparable to 1B from C. Then you would go in and you would edit your program and you would run it for the sequence in which it starts at 1. So your A is 1. And your D, how do we determine D? We take 8, subtract 1. We have a difference of 7. And for question 1D, it asks you to edit that for the sequence. And you need to determine the 15th term. So your n is going to be 15. So we can simply change this. So if your A is going to be 1 and 7 is your D and your N is going to be 15, and you'll be able to run your program and it should give you 99. So in a program like this, you can start your sequence at any value, right? If you have the equation incorporated in your function. And then when you call that function, it's going to plug in all of these values that you define in the main, and it's going to be able to produce. So for D, we simply change up the program. You have a starting, which is 1. You have a difference, which is 7. Okay. And then your N term is 15. And it seems repetitive for E. I just wanted to make sure that it gets reiterated for E. And then at the 15 term, so A of 15 would be, right? And here we would see that it is 99. I should type T of 15, not to confuse you there. So somewhat simple to really incorporate the arithmetic sequence equation. Nothing difficult in that, right? And so if you look at how the approach for this program is that we simply just use a function, we return from that function, and then we would use the main to declare our A, our D, and our N. And then also call the function and just make sure that you have the arguments. So now you would know how to write an arithmetic progression C++ program. So in the case that if I'm looking for, 115 location, it should be able to produce that, right? The value for that. So let me put this back before I forget. Any question with 1? So after you complete exercise 1, then we would move on to arithmetic series. Let me load that. So to elevate from exercise 1, which we simply just calculate the nth term value in the arithmetic sequence. In this one, the second problem or example, you would find that we would also calculate the arithmetic sum, or known as the series. Okay. So in the second part, it defines the series is the sum of the terms in the sequence. And we talked about Gauss Trick on Tuesday. So we can quickly use Gauss Trick to calculate the sum given the first, the last, and the number of terms. And I copy and paste the equation there for you in case you forgot. So in example 2, when we look at the program, again, we're using algorithm STL, IO stream for input and output. And we have a function called sum of AP. And in this function, we're going to pass A, D, and N. Those are the variables that's part of the equation. But you asked me, well, why are we using this just like how we used the last one, right? This is an iterative approach where you would do a running sum, meaning that you are going to add using a loop, and you're just going to add from the first to the nth term. We are not implementing Gauss Trick in this case. So you need to find the nth term so that way you can set up your loop. Okay. So here in the function, you initialize sum, which is at 0 to start before the loop. Then we have a for loop. And as it loops, it's going to add them together. It's like you manually add every number from left to right. So then we would have the sum, and sum is going to be sum plus A. And you can also do a compound assignment with that. But this is visibly easier for those of you who are new to C++. And since we're adding sum with A, we want to define what A is here for the function, that is. So A is going to be A plus D, right? So that means that I need to add the difference to go to the next term, which is the next number. And then we are going to return sum. That's going to give us the total, or the value that represents our series. So in the main, we are going to now initialize the value for n. And let me make sure that it matches yours. So hold on, let me fix this because I've changed this for the later exercise. So 5, 1, and 2. So we are going to add up the first 5 numbers in our sequence. And we're going to start with 1 as the value for the first term, the first number. Then we are going to increment 2, right? So it's going to be 1, 3, 5, and so on. So after we initialize the value for n, a, and d, because we have to subsequently find every value after the first value and add them up. Then we are going to call on the function, which allows us to loop and add. and that's going to give us our result. Okay, so here the program gives me 25. So the first step in number 2 is to put that into your IDE, run your program. Then we want to look at the calculation so we can verify. And so if you want to use Gauss Trick, you have to know the first, the last term, and the number of terms. So in order to do that, we would use the equation that we previously learned and used in the last exercise. We would then find the fifth term because we already know the first term. So for our fifth term, we would take A, which is 1, plus your N, which is 5, minus 1, times D, which is 2. So 5 minus 1 gives me 4. 4 times 2 is 8, plus 1, which gives me 9. Okay, you can fill in the rest there. So for 2A, it simply wants us to look at the sequence from the first term to the fifth term. And I had set that up for you so you can simply calculate and then put down your sequence. Then after we found the fifth term, we would then be able to apply Gauss Trick. So for Gauss Trick, it tells us that you would take the first term plus the last term, multiply it by the number of term divided by 2. So your first term is A is 1. Your last term, we found that from question 2A, which is 9. And because the program asks us to calculate the sum for 5 terms, so your N is 5, which is the number of terms. So then you would take 5 divided by 2, which is the number of term divided by 2. And we want to multiply it by 1 plus 9. So 1 plus 9 gives us 10. And 5 divided by 2 is 2.5. So 2.5 times 10 gives us 25. So now we can then verify that the program produced accurate results. Even though we are using iterative approach and not apply the Gauss Trick formula into our program. And you can definitely put in the Gauss Trick, right? You would simply have a function, just like what you've done in the last one, and then be able to say which is the first term, which is the last term, and then you would include the equation in that function, and then use main to call. So it's not difficult to do at all. So after we verify that 25 matches, okay, with the program output, we would create or edit the program to fulfill a different sequence. And in this case, your A is 4. Okay. So when you edit, I put a note here that you would use A is 4, which is the first value of the term. Then your D is going to be 10, because how do I know it's 10? It's 14 subtract 4, or 24 subtract 14, which is your difference or your distance between the terms. And then your N value, here it tells us that we need to find the sum from the first to the 30th term. So your N is 30. This is just a note, okay? So what you would need to do is you would need to go to your program, and then you change this up. Oops, 30 here. And then your A is 4 and your D is 10. Then you run. Now the second part of C, it asks us to determine the partial sum of the above sequence and take a screen capture of your change program. So to determine the partial sum, to verify that the program calculates correctly, we would then first find the 30th term value by using the equation we had previously used. So 4 plus 30 minus 1 times 10, which gives us 294. Then you are going to use Gauss Trick to find the arithmetic sum. So we would take 30 divided by 2, 30 for the number of terms, divided by 2 times it by 4 plus 294. So I would have 15 times 298. And I can use my calculator. Then I can check to see if that value matches. And it does. Okay. So it should be that either approach that you're using, whether you're using this approach that you see in the exercise with the for loop, or if you, like I said, incorporate Gauss Trick in equation into your function, you should have the same output. If you don't, that means that you're missing something. Okay. And function is super easy to write. So we can write one function to be able to determine the term, the nth term, like what you've seen in the previous exercise. Then we can have another function that's going to be determining the series or the arithmetic sum. And when you have a function that determine the nth term, once you find the nth term, then you simply plug that into the function for finding the total or the sum. Any question? Okay. So don't forget to provide screen capture for C, 2C. So after this, we should be able to explore ways that we can implement algorithm as, into functions and be able to utilize our function in the program. Okay. And there are many ways to really approach this type of program. You saw that, we talked about 2 ways, right? So when you think about solving a problem, something like this, how would you approach it? And, you can elevate it by implementing data structure in the case where if you have a very large sequence, okay? On the simple level, we are either using array or variables for most part, right? And then you can also think about how you want to implement pointer to point to certain values and so on, okay? So there are many ways that we can elevate this type of program and still be able to produce. Now, how you using memory and how you executing using processor to execute the task, that also play a big role in your performance. And we've been talking about that, right? Space and time. Any question on 2? Okay. Let's talk about number 3. So now let's say that you are going to give the user the opportunity to enter some value, like a starting value, the difference between the arithmetic terms and the total number of terms. So it will be able to produce, okay? So in example 3, now in this one, we're not using a separate function. You can definitely write a separate function for this part, okay? And again, this one is doing a running sum. Okay. So as you have the user input, we can keep it at int, but in the case where if they put a large value, we want to change up the data type there. So this one is only implementing the main. And in the main, what we're going to do is we are going to declare A, D, N, I, sum, and J. Actually, J is not even used. I don't know why I put that there. But anyway, your IDE should catch this. Okay. So J is not needed. You can take that out. It should run. Okay. All right. Then next, what we're going to do is we are going to, inside here, we're going to ask the user to enter a value for A. Then we're going to read that value and store it into the variable A. Then prompt the user again to enter the D value or the difference. And then store that into variable D. And then for the next one, we are going to prompt the user to enter the number of terms, which is going to be n. And after that, we would then have a for loop. It's going to start at the first value, which is a. So your I is going to start at a. And it's going to go up to, right? It's going to go up to the last value, which is going to be n times d plus a. Okay. Another way that we can approach this is we can look at the number of terms. Okay. And then we can separate it. Then you can nest it as a for loop. But anyway, this is going to go to the last term, which is going to be n times d plus a. Why doesn't it just go to n? N is only going to be the 30th location, but we want to use the first value and add it with this all the subsequent value all the way until the end. We're not adding the index, we're adding the value at that index. Okay. And we're going to increment based on the difference. So here we are going to do a running sum. And then we are going to see out. So your sum is going to be displayed as is the sum. So here we can test the program. So if we start at 1 and our difference is going to be 4, right, enter the number of terms. So if I go to 50, right, it's going to display every single term that it calculates as it loops. And it would end with the sum value. After it displayed the sum value, it would end. Okay, so here I would be able to see my entire sequence along with the sum of my sequence. Now this program, unlike the last two, you would see that we are able to display each of the value as well. Now a cleaner way to do this is that we can append it to a container and read from that container, right? Like we would put the calculation and we can point to it. So store it into an array and then read every single index. All right. So after you had put that into your IDE, you're going to run and we can test it based on what is required here, 3, 6, and 10. So let me rerun this and we can do 3, 6, and 10. So we have a difference of 6. We're going to go up to the nth term. It's going to add everything up. And it tells me here that I have 300 as a sum. So if we determine the series and you can use each of the value to check, right? So if I start with A, which is 3, for the first term, then the next term, that should be 9, right? Because 2 minus 1 is 1 times 6 is 6, plus 3 is 9, and so on. Okay, so this is going to give me 12 plus 3 is 15. So for my t of my 10th term, t of 10 is going to be 3 plus 10 minus 1 times 6, which gives me 57. Then for the sum, that will give me 5 times 60, which is 300, right? So here, using the calculation, we can verify that the program, even though it's using looping and we're using Gauss Trick, we have the same result. And as we explore the detail of the program earlier, right, the implementation of this program is to use this part. So for B, you need to explain, right, how it's able to disregard the equation, how it's able to find the sum of your arithmetic sequence in the example. Okay. The only equation that it implements, and you can expand on that, is the arithmetic sequence, right? You see that here. This is used to do what? To determine the next value in that sequence after the first. So we already gave it the first, which is 3, right? That's from the user input. Then subsequently, it's going to take that value and plug this into the equation, your arithmetic progression equation, and it's going to determine all the subsequent value, the next term, the next term, the next term. And as it does that, it's going to add them up and put that into the sum variable. And that's how we're able to achieve the sum of our arithmetic sequence. Okay. Now, can we make it shorter or not use a loop? We sure can. We just implement a function for Gauss Trick and then call that in the main. We can still have cin, we can still have user input. But ultimately with Gauss Trick, you're still going to have to find the last term, right? If you have the first term that the user enter, you still have to calculate the last term, add them together, and then take the number of terms divided by 2. So either way, we're still going to have to rely on the arithmetic sequence equation. Any question? Okay, so give me a brief explanation there for 3B. It is a short lab, so we only have one more to do. I guess in the next semester, I'll add the quadratic and make it a little bit more interesting. So the takeaway from doing this, right, is that you can see how we can approach to solve this type of problem in C++, how to use equation in the program itself, or we can just use looping. Okay, any question on 2? Okay, last one. Okay, we're gonna finish super early today again. All right, geometric sequence and series. So we also covered geometric on Tuesday, and geometric sequence, each of the term is found by multiplying the previous by a constant. Okay, so we would have a common ratio, and in this description, it talks about R as the common ratio. So the first term you would have A, and then the subsequent you have A times R, and A times R squared, A times R to the third, and so on. So to calculate any term in the geometric sequence, we learned also on Tuesday that we would use this equation. T of n is going to be equal to A times R, raise that to the power of n minus 1. Okay. And here we note that we use n minus 1 because A of R to the 0 is for the first term. If you take 1, subtract 1, you get an A of 0. That will be anything to the 0 is 1. 1 times A is A. So when we sum that up, we would use the below equation where it would be A times 1 minus R to the n divided by 1 minus R. So now we can approach it again with a for loop. Okay, but we do implement some of what was described for this particular example. Exercise 4. And let me make sure that my 1, 3, and 7. So let me fix this. Okay, and let me change up. Okay, so for future steps in this particular exercise, make sure that you check your type. If you're using decimal, okay, let me change this to int type. What happened? Okay. And then I wanted to make sure that this is it. All right. So here's my program. Should be matching what you have there for the screenshot. We have algorithm STL, IOStream STL, using namespace std. That's basically the standard, right? And then we have a function called sum of GP. And for the argument, we will use variable A, R, and N. We initialize sum at 0 before the loop. This is also another running sum program. So we just add them as we go. And so we would have for I is equal to 0. That's the first index. It's going to go up to the nth term. So it's we're going to stop at n or before n, right? And then we are going to increment. So sum is going to be sum plus a, and a is going to be a times r. Why is that? Because, right, we talk about the common ratio. We're going to take the previous value times that common ratio, and we're going to go through and loop through, and we're going to add them. And we're going to return sum. Our first term in the main, we initialize the first term at 1. And for the common ratio, we have it as 3. And then the term that we're going to go up to is going to be 7. Then when we output, we simply call the function with its respective arguments. And that's it. Okay. And if you want to be fancy, you can add in a string and say the sum of the geometric sequence is, right? So we see that it's 1093. With that, after we run the program, take a screenshot. Then we want to verify with the calculation. So using the function that's provided or the equation that's provided, T of n is going to be equal to a times r raised to the power of n minus 1. Then we want to find out each of the value. So we already know that 1 is given to us, but if you plug that into the equation, it should be the same. So 1 minus 1 here is 0. 3 to the 0 is 1. 1 times 1 is 1. And then T of 2, that should give you 3, and so on, right? You don't have to write all of them. Just, I want to make sure you know how to be able to calculate it. So T of 7 should be 1 times, and then we would take 3, which is your r, and raise it to the power of 7 minus 1, which is 6. Okay, so 3 to the power of 6 is 729. Now to calculate the sum of the 7 term, we would take the equation a times 1 minus r to the n divided by 1 minus r. So plug in your a, which is 1. And then plug in your n, which is 7, divided by 1 minus 3. And then plug in your r for the second part, or the third part, sorry. Okay. You can put that into your calculator and verify if it's correct. Okay. Any question? Okay. So after you have calculated out for A, you find the sum of your geometric sequence. Then what you want to do is to modify the program where your A is going to be 2, your R is going to be 1/4, or it should be 0.25, which use floating points. And your N is going to be 8. So I note that you need to make sure that you adjust the data type accordingly, as you saw earlier. Let me see if I can do Control Z on this now. It's saving. Okay. And don't forget that when you sum it up, it's also a flow. That's just allowing it to store. So, and then if you want to set precision, you can also set precision, but I don't require that. So for B, just make sure that we accommodate the fraction. You can use decimal in your C++ program. And then you need to run the program, give me the screen capture and output. Okay. Then we also need to verify that our output in our program is correct. So we just need to find the sum. And we also need to determine the sequence. So using the equation, you just plug 2 in for A, right? 0.25 or 1/4 for R. And N is going to be 8. And then plug in the R for the division. You can use fraction or decimal, that's fine with me. Probably easier on the calculator using the decimal. So once you have the output, right, check to see if your program produces correctly. Any question? Then we would then explain the algorithm of the program. So coming back here, focus on, right, how this function is defined. We have a loop and we're getting a sum. What is it adding? Every value. So as it loops, it's going to generate the A, or the value at that term, right? And it's going to take that A and it's going to multiply it. So how is the A? The A is going to be A times R. So it's going to take the previous number and multiply it by the common ratio, and then it's going to add it to the sum. So we are doing a running sum in the loop. Okay. So for D, you just have to explain how the algorithm is designed in that program. Any question? So taking this, right, this is the geometric, and you saw how arithmetic is done. You can think about how that would, you can elevate it to use that for quadratic, where quadratic would be that we have two level of differences. If you loop it, would you consider having an inner loop and an outer loop? And how would you design that? Okay. So in the number 4, the only area that we would see that equation is somewhat implemented was in the A, where we would say that A times R, right? We don't truly implement the full equation. You can definitely write a function, just like I said with the other one, with straight equation and be able to return from it and then take the value, right? And then have another function and do the sum for it. However you want to approach that. But in this approach, we simply just generate the value and add it as we go up to the number of terms. I have a chat question. So for part A of example 4, the denominator is 1 minus 3 is a negative, but why is the sum positive? Let's come back to here. Okay, so we have 1 times, let me see if my, okay, I see what you mean, like for the 1 minus R. But because when you do, I think I have a mistype, 1 minus R. Let me retype that. So 1 minus R to the n divided by 1 minus R. Okay, so 1 minus R to the n. Thanks for catching that. I didn't catch that. One minus 3. It should be positive. Okay. Does that clear it up now? So when you take 1 minus R divided by to the n minus divided by 1 minus R. So 1 minus 3 to the 7 is a negative number divided by 1 minus 3, which is also a negative number, which gives you a positive number. Yeah, sorry. I don't know why I had typed the 1 slash, but okay, that's corrected now. Let me check the other one. Oh, that was it. Other questions? Okay. So just that's all we need is to modify and explain the algorithm of your program. And then let me fix this one too. Okay. I think I have one too many bracket there. Yep. Okay, so for 1C, we just find the sum. You can plug it into your calculator. You can write it this way, 2 times 1 minus 0.25, and then raise that to the 8, if that's easier for you to see, divided by 1 minus 0.25. Okay, so put that into the calculator, explain, and that wraps up our lab for today. Okay. And then check your answer. Any question? Okay, so if you are finished today, you can turn that in and then have a good night. Enjoy your evening early. If not, I'll stick around for a little bit for questions. And you can turn that in on Sunday if you don't want to finish it today. Okay, I know that this is week 8. A lot of classes are having midterms and things. But if you take care of it now, you have the weekend to relax and not think about tests and assignments. And if you want to pre-read, okay, and let me go back to modules. I do have a course plan weekly schedule. It tells you on that page what each week would be. But for unit 9, we're going to cover induction and recurrence. And then we are going to cover chapter 12 and 13. So if you want to pre-read that, you can. There is going to also be a homework assignment next week for the next quiz. And so it's going to be open for the quiz is going to be open in week 10, and week 10 we're going to cover graphs. Okay. So I will open your project either late next week or at the beginning of 10, which if I do open it during week 10, it should give you about 6 weeks to work on it. And then we'll talk about the project and the team, possible team if you want to work in team for this class. I encourage you to. I'm not going to force you to work in team because it's hard to work in team if you're not familiar with using virtual environment with team. So we'll touch on that. Okay, and you can sign up and communicate with your team. But definitely every feedback that I have for my project is that the students, they said that they wish they work in teams. So let's think about how you're going to be able to set your schedule aside and be able to work with another person or 2 other people in your group for the project. okay? And it is a programmable project, so you can't, you know, there's different portion in which you have to describe what it is, how you solve it, how you implement your algorithm in C++, and you apply the concept from this class. Okay, so I'm going to go ahead and stop recording.